Square root of a function. The function y equals root f of x is the square root of the function y equals f of x and is defined only for where f of x is greater than or equal to 0. So the function y equals root 2x plus 1 represents the square root of the function y equals 2x plus 1. Let's look at an example. Given that f of x is equal to 3 minus 2x, graph the original function and y equals root f of x. So let's start by graphing y equals 3 minus 2x. I'm going to do some rearranging and put the x term first and the number at the end, because now it's in slope-intercept form, which makes it easy to graph. So graphing this function, I have a y-intercept of positive 3 and a slope of negative 2. So that means down 2 over 1 to get to each of the next points. Let's draw a nice straight line, hopefully to connect those. Now we're asked to graph the square root of this function. When we take the square root of this function, what we are doing is taking the square root of each of the y values. Anywhere that original function is less than 0, so this first part of our graph, the square root function will be undefined, so we won't have any points there. If we look at this first point then, where the original function is greater than or equal to 0, so at this point the y value is 0, the square root of 0 is 0, and so our square root function will be an identical point. Let's go up to where y is 1 on our original function. The square root of 1 is also 1, and so there's a second invariant point there. What happens in between those 2 points? If I look at a y value of 1/2, the square root of that is a number that is slightly larger than 1/2. And so all of the values in between 0 and 1, when we take the square root, are going to become slightly larger. I can then pick some different points along the original function and take the square root of that value. So for instance, where my original function is equal to 4, the square root of 4 will be 2. Where the original function is 9, the square root of 9 will be 3. And so my graph would continue in this manner. Let's look at the domain and range of each of these. So the domain for the original function would be from negative infinity to positive infinity. It extends indefinitely in both directions. The range will also be negative infinity to positive infinity. However, for our new function, the domain has to start where where the function has a y value of 0. And so in this case, it would be at the point 1.5. It's difficult to see from my graph, but that would be the starting point. So the smallest value in the domain would be negative infinity up to positive 1.5. The range is going to go from 0 up to positive infinity. Let's look at a couple of more examples, but this time I'm going to give you a graph of the original function. So again, anywhere where that original function is below 0, we don't need to worry about because the square root function would be undefined. We will always have 2 invariant points. The first one, or at least 2, the first one will be where the original function is equal to 0, or anywhere that the original function is equal to positive 1. If I take the square root of anything between 0 and 1, I get a slightly larger value. The square root of 4 is 2, so that point will drop to here, and my graph will continue like this. What happens if that original function is a quadratic value? Again, the part of the graph that is below the x-axis has a y value that is less than 0, and so won't be part of my square root function. Invariant points will occur anywhere where the original function is equal to 0, because the square root of 0 is still 0. So I have invariant points here. I will also have invariant points anywhere where the original function is equal to 1. So I have 2 more invariant points here. In between 0 and 1, the square root is a slightly larger value. So both sides are going to look like this. Where the original function was equal to 4, the square root will be 2. And so the right-hand side will continue in this manner. On the left-hand side, I also have a y value of 4. So the square root is 2, and it will continue out in this direction. The shape of that graph can change depending on whether your parabola opens up or down.